This video will cover the first page of notes for the topic of rational functions. The first thing we want to do is review the definition of a rational function. All it is a polynomial in the numerator and a polynomial in the denominator, but we got to make sure that the denominator does not equal to 0. Remember that if we have a fraction with 0 in the denominator, then it's considered undefined. So let's review our two basic reciprocal functions that are in the form of a rational function. One of them would be the reciprocal function of y is equal to 1 over x, and I've graphed it here, and the reciprocal squared, which would be y is equal to 1 over x squared, and I've graphed it here. You can see these in your parent functions on page 57 and 58. The next thing we should be able to do is to determine the domain and range for each one. Again, this information may be found on your parent functions page. But I just want to remind you that we can take a look at our graph and see that we have graphs for negative numbers, we have graphs for positive numbers, but we do not have anything when x is equal to 0. So you can see the domain will say that for both functions. The range, notice we do have negative values in the y values here and positive y values here, but we never actually touch the x-axis, so we do not have any values for the y to equal to 0. Over here on the reciprocal squared, we see the same idea, but notice we do not have any y values that are negative. So you can see that our range is only going to be from 0 to positive infinity. Another bit of information that we can probably see from our parent function pages is increasing and decreasing intervals. So I just wanted to make sure I reminded you of those as well. I'm going to use a highlighter so that you can see that going from left to right, we can see that we're coming from negative infinity. We can see our y values are doing this, and we can see that they're constantly decreasing. I know it looks horizontal right here, but remember that it's getting smaller in terms of a more negative number, more negative number, more negative number. So we can see that it's decreasing from negative infinity to 0. And then when we jump over, if we start back up here, we can see that it's coming down, down, down. And likewise here, it's getting closer and closer and closer to the x-axis. So we can again see that it's decreasing here. Notice we can't say it's decreasing from negative infinity to positive infinity because we don't know what's actually happening right here when x is equal to 0. So we do have to keep them as separate. Let's do the same thing for the 1 over x squared function. Starting from the far left, we can see that it's increasing values is going to go upward. So we can see that it's increasing from negative infinity to 0. Then it jumps over to the other side, and then it starts coming down closer and closer to the x-axis. So we can see that it has a decreasing portion as well. The next thing I want to talk about are end behaviors. So again, remind yourself that in behaviors, we always see what's happening to the left, and we look at as x approaches negative infinity, and then we're going to see what happens as x approaches positive infinity. So let's just first look at our reciprocal function. We want to know what happens as x approaches negative infinity. So I'm going to start here at 0, 0, and I'm going to go towards negative infinity, and we can see our y values here are getting closer and closer to 0. So we would say y is approaching 0. If you want to be fancy in pre-cal and calculus, we actually say it's approaching 0 from below. You will only be required to tell me that it's approaching 0. If we go to as x approaches positive infinity, notice we're going to go from 0, 0, and we're going to go outward towards positive infinity. We see that our y values on our graph are getting closer and closer to 0. And this one's above the x-axis, so we would probably say from above. Again, you will only be required to tell me that it's going towards 0. So that's where you see right here my information that I wrote about my y values in terms of our end behaviors. Let's do the same thing for the reciprocal squared function. Again, we're looking for the end behaviors. What happens as we get towards negative infinity? Well, the y values are coming down, 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 closer to 0. So we would say as x approaches negative infinity, y approaches 0 from above. Again, you're only going to be required to tell me that it approaches 0. If we go towards positive infinity, as x approaches positive infinity, the y values are coming down closer and closer to 0 as well, but they're doing that from above. And that's how you can see when we talk about our end behaviors here. Finally, the last thing I want to talk about on this page is going to be vertical and horizontal asymptotes and what they look like in terms of our graph. So if I come back to my graph, we will see that we have for our reciprocal, we have a vertical asymptote right here. That's where that break is. When we talk about it in upper math classes, we'll see that what happens is that we are looking at the x values and we're seeing that the x values are approaching 0 and the y values are going in opposite directions or in the same direction towards infinity. But for us, all we need to recognize that it's going to be the break in our graphs where the denominator is equal to 0. So in our case, our denominator is x, so x is equal to 0, and that is going to be the same thing as the y-axis. If we look over here for reciprocal squared, again, if we let the denominator equal to 0, we'll find it to be at x is equal to 0. This is going to be our vertical asymptote. For our horizontal asymptotes, I'm going to put them a little thicker in red. Horizontal asymptotes are actually what our end behaviors are telling us, and that is, and for the reciprocal function, it's going to be this y value here. As the x values are going to negative infinity, the y values are getting closer and closer to 0 on this end. And it's getting closer and closer to 0 here, so that horizontal asymptote is going to be the value when y is equal to 0. It's the x-axis. And we'll see the same thing over here with reciprocal squared. The y values at the end behaviors are going towards 0 as well, so the y value is equal to 0. So let's come back down here, and we can see that we have vertical asymptotes and horizontal asymptotes. We're going to talk a little bit more about vertical asymptotes in a minute, but I want to let you know the relationship between the end behaviors and the horizontal asymptote. They actually tell you the horizontal asymptote. If you know the end behaviors, then you can tell me the horizontal asymptotes, or vice versa. If you know the horizontal asymptote, then you can tell me the end behaviors. And that concludes this video.